Welcome to The Explainer. I'm your master coach, and today we are dissecting one of the most rigorously assessed, fiercely debated, and frankly misunderstood components of the Cambridge AS and A-Level Mathematics 9709 syllabus. We are talking about foundational trigonometry. Specifically, we're locking in on the core identities, sine theta over cosine theta identically equals tangent theta, and sine squared theta plus cosine squared theta identically equals 1. Now, you might be thinking, I already know these formulas, I've memorized them. But let me stop you right there, because today isn't about rote memorization. Today, we are going to navigate the intricate, highly specific Cambridge marking grids. We are going to pinpoint exactly where top candidates secure their marks, and conversely, where average candidates bleed them. We're also bringing in two of our revision avatars today, Alex, who loves raw facts, and Sam, who loves fast arguments, to show you exactly how to engineer a flawless, top-tier mathematical response under extreme pressure. So let's dive right in.
Listen to this quote closely. The difference between a B and an A star in mathematics often comes down to how well you understand and manipulate these two core trigonometric identities. That insight right there, it's pulled directly from the examiner's playbook. It is absolutely crucial to realize that it is not just about memorizing these formulas, it is about completely understanding their theoretical architecture. According to global Cambridge Principal Examiner reports, candidates who simply drop these identities onto the paper without context, well, they remain permanently stuck in the middle marking bands. They hit a ceiling. Top-tier candidates, the ones pulling the A stars, they do something totally different. They demonstrate evaluative thinking. They use these exact identities to question assumptions, to execute systematic analysis with crystal clear working, and to forge causal relationships across entirely different areas of the syllabus. Today, our ultimate goal is translating those theoretical principles into an absolute maximum mark yield. We are going to turn your theoretical knowledge into a fully optimized exam strategy.
To get there, we are going to follow a highly rigorous, time-blocked structural blueprint. 1. Deconstructing the target question. 2. The strategy debate. 3. System upgrade. 4. Visual workshop. And 5. Ultimate strategy recap.
Section 1. Deconstructing the Cambridge target question.
Okay, I want you to imagine you are sitting in the exam hall. You open the paper, and you are staring down a high-tariff, multi-part Cambridge past paper question asking you to prove a complex trigonometric identity. Your heart rate spikes. What do? When tackling a high-value target like this, your conceptual framework has to draw on systematic analysis. If you just rush to substitute sine squared theta plus cosine squared theta for 1 without clearly showing the logical steps that led you to that exact substitution, you are literally bleeding method marks. Cambridge uses specific assessment objectives, or AOs, to grade you across very distinct cognitive domains. We always start at the foundation with AO1, which is knowledge and understanding. This is your ability to simply recall the identities. But here's the reality check. You absolutely cannot get an A star with AO1 alone. Not a chance. As we scale up the examiner's grid, we hit AO2, application. This involves using appropriate mathematical terminology and actively manipulating the identity to fit the problem. Finally, we reach the apex, the holy grail, AO3, critical analysis and evaluation. This is where you integrate this trigonometry problem with other syllabus areas, like calculus or mechanics. Examiner reports explicitly highlight that candidates who reference these cross-topic connections achieve significantly higher marks. It's about showing the examiner you see the whole board, not just one piece.
So, to consistently hit those top AOs, those high mark bands, we have to ask a critical, sometimes uncomfortable question. Why do students find interpreting complex texts and data so hard? Seriously, why do brilliant, hardworking scholars walk out of the exam room feeling totally confident only to open their results and see a B? It almost always comes down to one thing: command words. Command words are the specific instructions hidden right in plain sight at the start of the prompt. When Cambridge asks you to analyze, they want you to explicitly deconstruct the problem into logical steps using your identities. But if the command word is evaluate and you merely provide an analysis, you have completely failed the objective. Evaluation requires identifying limitations, testing boundaries, and considering alternative interpretations of the mathematical model. Misinterpreting these words triggers an immediate, non-negotiable penalty on the examiner's grid. It caps your score instantly, regardless of how flawless or beautiful your algebra is.
Section 2. The Student Collaborative Strategy Debate.
To really understand this, let's head into the study suite with our two revision avatars, Alex and Sam. I want to show you exactly how different strategies clash when facing a brutal 8-mark proof question that requires extensive use of both the tangent and Pythagorean identities. Alex, our first student, represents the flawed, traditional approach.
Alex operates on the assumption that simply dumping every known formula onto the page and violently grinding through the algebra is enough. I'm listening to Alex argue right now, saying, look, the examiner just wants to see that I know sine squared plus cosine squared equals 1. I'll just write the raw facts, do the substitution, and get to the end. Alex is aimed purely for that basic AO1 tick, but Sam, our top-tier candidate, pushes back hard. Sam recognizes that writing down formulas without building an analytical thesis link misses the point entirely. Sam says, Alex, if the command word is explicitly show that, you need state exactly why you are making that specific substitution at that exact moment. Sam argues that writing, by substituting the Pythagorean identity into the denominator, we isolate the sign variable, is how you build a causal bridge. That evidence-based reasoning, that explicit communication of your mathematical intent, is exactly how you unlock the AO3 marks that Alex is leaving on the table.
Let's look deeper at their debate, specifically when they try to decode these Cambridge command words using a matrix. Notice the immense difference between a simple statement and an analytical link. Alex drafts a topic sentence and writes, substitute tan theta for sine over cos. That treats a high-level command word as a basic state instruction. It's too simple. It's a B-grade answer at best. Sam steps in, shakes their head, and rewrites this live to say, to analyze the relationship, we apply the identity sine theta over cosine theta identically equals tangent theta to the left-hand side, expanding the expression to reveal common factors. Do you hear the difference there? That version hits the analyze command word perfectly. It identifies the key mathematical elements, it applies the relevant principles, and it explicitly states the causal relationship. Sam and Alex are arguing over this, but Sam is right. You have to mold your response to the exact restrictions set by the command word.
At this point in the study suite, I always step in as the coach to validate Sam's need for structure, because the presentation of information in Cambridge mathematics follows strict, unyielding conventions. If you ignore these conventions, you bleed method marks faster than you can count. Proper headings for your steps are absolutely essential. You must use correct terminology. Like, instead of writing, I swapped it for tan, like you're texting a friend, you must write, I applied the tangent identity. You have to use appropriate formats. That means aligning your equal signs vertically down the page and clearly denoting the left-hand side versus the right-hand side. Clear annotation is non-negotiable. Principal examiner reports reveal year after year that candidates consistently lose critical marks simply by confusing key terminology or failing to define their terms before executing an extended mathematical proof. You have to treat your paper like a professional mathematical publication.
Section 3. Mid-video system upgrade and channel transmission.
Okay, strategy check. Before we unlock this top-band paragraph structure to help you completely crush your upcoming sessions, you need to make sure your revision feed is perfectly optimized. Take a second right now to subscribe to Ace the Exams at the handle @AceTheExams and enable all notifications so you literally never miss our weekly Cambridge exam breakdowns. It doesn't matter if you are sitting for IGCSE, O-levels, or AS and A-levels. We are building the ultimate framework for you. Hit that bell icon right now to lock in your system upgrade. Okay, let's get back to the matrix.
Back in the study suite, Alex and Sam have hit a massive roadblock mid-paragraph. Their algebraic evidence is failing to link back to the main thesis of the proof. They are losing the structural narrative. When this happens, you need a universal framework. So I deploy the deconstruct, solve, evaluate procedural matrix for them. It's a 5-step system. Step 1. Identify given information. Extract only the relevant data from the prompt. Step 2. Break the problem into logical steps and select your analytical framework. Step 3. Solve systematically, executing analysis with clear working and notation. Step 4. Check for reasonableness and verify your intermediate results. Step 5. Make justified recommendations or comprehensively verify the proof. I make Alex and Sam rewrite their block line by line out loud using this. Alex starts. Step 1. Given the equation, we identify the tangent function. Sam follows. Step 2. We select the sine over cosine framework. By forcing this sequence out loud, they move from explicitly stating intent to executing algebraic division clearly for method marks to concluding with a verified, top-tier, examiner-compliant response block. This is how you engineer perfection.
Section 4. The Interactive Pause and Practice Visual Workshop.
I want to test your visual data scan skills right now under pressure. Imagine you have a complex trigonometric graph interwoven with a dense case study on your paper. Maybe it's modeling the oscillating motion of a pendulum governed by these very identities. I am putting 60 seconds on the clock right now. Your objective? Extract the highest yielding core trend before that timer runs out.
Are you getting distracted by the raw numbers? Or are you actively looking for the causal relationships? The clock is ticking down. Can you see exactly where the tangent identity is required to find the rate of change? Top-scoring candidates do not just look at the lines. They demonstrate evaluative thinking by questioning the assumptions built into the model itself. In those 60 seconds, they might recognize that as cosine theta approaches 0, the tangent function asymptotes, indicating a massive physical limitation in the pendulum's mathematical model. Spotting that physical limitation and explicitly linking it back to the denominator of your identity is exactly what secures those elite AO3 marks before the clock hits 0.
For Challenge 2, let's spot the examiner trap. I want you to look at a flawed, medium-tier student approach to solving an equation involving tangent theta and cosine theta. The student writes, change tan to sine over cos, cross-multiply, square both sides, solve for theta. Okay, locate the exact line where poor logic drops the mark. Do you see it? Let me get my digital highlighter. Right there. The moment they squared both sides without stating the explicit mathematical assumption that they might introduce extraneous roots, they entirely failed the procedural framework. An examiner compliance path looks fundamentally different. Let's trace it. A top-tier candidate writes, apply identity, tan theta identically equals sine over cos. Multiply by cos theta, explicitly noting cos theta cannot equal 0. Square both sides, acknowledging the potential for extraneous solutions. Defining terms, stating limitations, and executing systematic processing. That is how you achieve full examiner compliance, step by step.
To absolutely cement this concept, let's look at the most critical data pulled straight from the source material. These are the top 3 examiner warnings regarding these specific trigonometric identities. Warning number 1, students forget to include proper format. You are losing easy foundational marks by simply dropping the identity symbol, forgetting to write the theta after sine or cosine, or writing incredibly messy, ambiguous fractions. Warning number 2, students forget to check presentation. Your working must flow logically down the page, step by step. It cannot be scattershot across the margins of the paper like a rough draft. Warning number 3, and this is the biggest one, answers are not specific to the context given. If the question models a physical triangle, a negative angle might be mathematically derived, but it is physically impossible. You must evaluate your evidence quality, identify limitations, and ensure your final conclusions are heavily anchored to the specific, real-world context of the exam question.
Section 5, the ultimate strategy recap and outro.
Back in the suite, Alex and Sam are reviewing their final, high-scoring response text. Alex realizes that factual recall is just the starting line, and Sam acknowledges that pacing without precision is useless. Let's distill this entire rigorous session down into 3 universal Cambridge operational rules for maximizing mark yields under extreme pressure. First, the 3-step question scan. Before your pen ever touches the paper, identify the given information, locate the specific command word, and select the exact analytical framework required. Second, the marks per minute formula. In a 9709 paper, you do not have the luxury of getting stuck and staring at the wall. Allocate your time strictly based on the tariff of the question. If it is a 3-mark method question, execute the procedural sequence efficiently and move on. Third, the post-writing compliance audit. In the final agonizing minutes of your exam, audit your compliance. Did you include proper headings? Is your terminology perfectly precise? Did you explicitly reference the required identities? Follow these 3 rules and you mathematically maximize your yield.
I'm going to drop one final highly actionable memory hack directly from the source material to help you retain this theoretical architecture. Examiner reports actually suggest creating your own mnemonic for these 2 identities using the first letters of key terms. For the tangent identity, you might visualize sine over cosine equals tangent, SOCT. For the Pythagorean identity, sine squared plus cosine squared equals 1, SS plus CS equals O. Find a weird, memorable phrase that sticks in your brain and write it at the very top of your rough paper the exact second the exam begins. Why? Because under severe stress, your working memory shrinks. By doing this, your foundational AO1 knowledge becomes instantly accessible, completely freeing up your mental RAM for the heavy, high-yield AO3 analysis you're going to need.
All right, we have successfully deconstructed the target question, we've navigated the strategy debate, upgraded our procedural systems, and audited our compliance. The architectural blueprint for achieving top marks in Cambridge trigonometry is right in front of you, waiting to be applied to your past papers and revision drills. The strategy is crystal clear, but the execution is now entirely in your hands. So take action right now. Subscribe to Ace the Exams at the handle @AceTheExams, ring that notification bell for our weekly grade masterclasses, and drop a comment below sharing exactly which Cambridge subject and level, IGCE, O-Level, AS, or A-Level, you are preparing to conquer next.
The only question left for you is, when you sit down in that exam hall, will you just be reciting raw formulas, or will you be speaking the examiner's language? Catch you next time on The Explainer.